Welcome back, Grade 6, to Nelson Math Chapter 2, Section 7. Today we are rounding decimals. Before we get to the decimal part of it, I would like to quickly review rounding in general. Before we go ahead and review the rules that you've learned in previous grades, I want you please to keep in mind to make sure when you round any number that it actually makes sense. In certain cases, rounding doesn't make sense. We can't, for example, have 0.3 of a person, for instance. It has to always be rounded. But when you're asking yourself, does it make more sense to round up or round down? Please make sure you have a reason to do that. Today, we don't really need a reason to do that because we're looking at the pure rounding. In a previous grade, you probably learned 5 and above, give it a shove, 4 and below, put it down low. That's an amazing thing to know. I would also like you to remember that when you're rounding, to please have a good reason to round and ask yourself why you are rounding. Like I said, it's not really that important in today's section because we're just doing very basic rounding. But as we go through the rest of the year, you're going to be doing rounding for estimating and for other calculations and operations that may or may not make sense when you simply follow a rule. So let's take a look. Here we have the number 683, and we're going to round to the nearest hundred. The 6 right now is in the hundreds column, so we have to look one column to the right, and that's the 8. 8 is 5 or more, so we're going to round it to the number 700. That follows our rule. For 683, we're going to round the nearest 10. So the 10 number in this for this digit is an 8. So we're going to look one to the right, that's a 3. 3 is 4 and below. So we're going to call this one, we're going to round this one to 680. 680. That's how we are rounding these numbers. Let's continue with another number. 519 rounded to the nearest 100. So here's the 5. So that's the 100 column. So we're going to look one to the right, and that's a 1. That is forward below. So we're going to round here to, for the nearest 100, 500. And for 519 rounded to the nearest 10, we're going to round this to 520. So now we have our 2 in the tens column. So everything to the right of what we are rounding to will be a 0. Let's start from the top and see how. For this top number, we're rounding to the nearest 100. So we have a 7 in the hundreds column. Everything else will be a 0. For 683 to the nearest 10, we're rounding to the 8, to the tens column. So here's our 8, and it's a 0 to the right. Same thing here. We're rounding to the nearest 100 where there's a 5 and zeros to the right. Here we're rounding to the nearest 10 and zeros to the right. So that's our review of rounding, but we are going to now do a bit of rounding with decimals. 3 asks, model each baseball player's batting average on a thousandths grid. Round each number to the nearest hundredth. About how many times in 100 at-bats would you expect each player to get, how many times for each player to get a hit? D, round each batting average to the nearest tenth. And E, about how many hits in 10 times at bat would you expect each player to get? So this one I've already filled in for Zahn. That's a 0.367, or batting 367 in baseball terms, but math terms we're going to call it a 0.367. So right here we can see we have 3 tenths, 6 hundredths, 7 thousandths. So I've written it here in red. I'm showing it in red. Here we have 1 tenth, 2 tenths, 3 tenths, 1, 2, 3, 4, 5, 6 hundredths. And if you look closely, we have 7 of these small rectangles filled in. So this would be modeling the 0.367 on a thousandth grid. Round the number to the nearest hundredth. So the nearest hundredth would be filling up or having empty one of these squares here. So this square right here is clearly more than half. So to round it, we are going to finish filling in this square. So for rounding 0.367 to the nearest hundredth would be 0.37. I want to point something out. The answer is not 0.370 because that would be rounding it to the nearest thousandth. But the question's asking only to the nearest hundredth. So that would be 0.37. Those two would be equivalent. They have the same value. 0.37 is equivalent to 0.370, but they can have different meanings. For this question, they are equivalent. But in future questions, you're going to see how those two numbers are in fact different. C. About how many hits and 100 at-bats would you expect each player to get? Now, because it's 37 out of 100, or 37 100ths, we would expect approximately 37 hits. For D, round each batting average to the nearest tenth. So for Zahn, if we round it to the nearest whole column, because that's 1/10, we would expect it to be about 0.4, and we've just rounded that to the nearest tenth. However, if he was taking 10 at-bats, we would expect him to possibly get 4 hits in those 10 at-bats. But we would also expect to get 3 hits. We're rounding that because 0.367 is not that far away from 4, but it's not that close either. This is one of those examples where rounding might not give the whole picture. Let's move on to Johnson. We're doing the same with Johnson. So here you see Johnson with 0.270. Our 0.270 has already been shaded in red. And B is asking, round each number to the nearest hundredth. Well, 0.270, you might think it's already rounded to the nearest hundredth, but it's not. It's rounded to the nearest thousandth. We have to change that to 0.27 to get it to round to the nearest hundredth. Because once there's the 0 to the right of it, even though it doesn't add value to it, it can change the definition of it. So C is asking about how many hits in 100 times at bat would we expect? And this would be approximately 27, because 27 hundredths means 27 shaded out of 100. So we would expect approximately 27. For D is asking round to the nearest tenth. So to round to the nearest tenth, once again, we want an entire column to be filled in. So these 7 red pieces would be closer to having the whole column filled in than having just 2 columns filled in. So D would be 0.3. And if we were looking at how many hits in 10 at-bats, we'd probably predict 3. And our last one that we're going to be doing is Clark. So for Clark, B is asking round the number to the nearest hundredth. Here we have 0.217. The nearest hundredth would be 0.22, with the 1 being in the hundredth column, and the number to the right of it is a 7. That's 5 and above, so we're going to round it to 0.22. C is asking how many hits in 100 times at bat would we expect? We'd probably expect 22. For D, to the nearest tenth, that's about 0.2. And how many times would we expect him to get a hit in 10 at-bats? That would be approximately 2. Notice the way we can use just this one grid to show all those different numbers. We can show it for Clark. We can show it as 217 out of 1,000. That's where we use all the little rectangles here. We can label it as 22 out of 100. That would be the equivalent of 22 of these squares, like this. So 1, 2, 3, 4. We keep counting, 21, 22. We can show it that way. Or if we're showing tenths, we can show how 1 column is 1/10. So 2 columns is 2/10. Thanks, everyone. Have a good day.